Math Analyzers. We are going to look at Chapter 6, Lesson 8, all about sum and product rules for our roots. So, in the last lesson, we put together all the algebraic work with the graph and made the connections about what the roots are, where to find the axis of symmetry depending on the form of your quadratic function, and how to find the y-intercept, how to find the x-intercepts, how to then graph it using our graphing calculator. You can even still see it's still here, right? So we are looking at today something called the sum and product of the roots. And now before I go anywhere further, I need to very, very emphatically remind you that sum means adding and product means multiplying. Because if those two words aren't things you remember, you might get confused about what we're doing with our values in our roots. So to go back even further, remember when we did lesson 6 and we said the discriminant determines the type of roots. And I said we've got 4 different types of roots we could have: 2 rational, 2 irrational, 2 imaginary, or 1 real. And I reminded you that that 1 real really is 2 roots, but they come out to be that same value because they end up being the same as the vertex. Well, sum and product of the roots means taking those 2 roots and adding them together or multiplying them together. It turns out there's actually a way that you can figure out what the sum and product of the roots are if you have your quadratic in standard form. So if you have your quadratic in standard form, the formula for sum of the roots is add up your 2 roots, so root 1 and root 2, add up to negative b over a. And if you multiply your 2 roots together, so root 1, times root 2, multiplies together to give you c over a. So yeah, they're fractions. I mean, most of the time, a is 1 in what we've looked at so far. I mean, obviously we're algebra 2, so it won't be the same anymore, right? But we can figure out what the sum of the roots is and what the product of the roots is, and sometimes use that to go backwards and find the actual roots or the actual equation. That's what we're going to do today. So more algebraic work with our parabolas. Now, here's an example of the formula at work, okay? This is a quadratic function that we have actually looked at prior to now, so you've seen this one, where my answers are negative 2 and 4 for my roots. Add those up. What do you get? You get 2, right? The formula for sum of the roots is negative b over a. Well, look, the b value is negative 2 divided by 1. Negative of negative 2 is 2 over 1. There's the sum of the roots, 2. The product of the roots means just multiply them together. Well, negative 2 times 4 is negative 8. It is the c value. If you have an a value, if you have an a that's different than 1, then yeah, it'll be fractional, but that's what that comes from. So you can see these answers now for what the sum of the roots will be and what the product of the roots will be without actually finding the roots. Or you can use those values to help you find a missing root. Or you can use those values to help you find the equation of the quadratic. That's what we're going to be working on. So at first, let's just use the sum and product rules to find the sum and product of some of our roots. Oh, there's another example. Sorry. So there's another example of that happening. Okay. Now, without solving, find the sum and product of the roots, because that's the key here. Is if you solve these, yeah, you can just add up and multiply the 2 numbers, right? But we're saying don't even bother solving first and finding the roots. Just tell me what they are based on the formulas. So the sum of the roots is negative b over a, and the product of the roots is c over a. Okay, so notice again, opposite sign here. So I've got negative of negative 3 divided by 2. My a value is 2, right? So what do I get for the sum of the roots? It's 3/2. There you go. Will you get a fraction? Yeah, it's all right. Here, product of the roots is c is -2 over 2. If it can reduce, do it, and we get -1. Your sum is 3/2. Your product, -1. Let's do it again over here. You got to get standard form first. So negative 9x squared minus 8x minus 15 equals 0. Now you can use sum as negative b over a and product as c over a, right? So sum is negative of -8 over -9. So positive over negative. So we still get -8/9. Product is -15 over -9, negative over negative, both evenly divisible by 3. So product is 5/3. There you go. That's it. Didn't have to solve to find those. Didn't have to solve anything to find those. Now what we're going to do is we're actually going to write out the quadratic equation given only the roots. So I've been given the roots here. I'm going to add them up, and that will help me find my b term and my a term. And then I'm going to multiply them together, and that will help me find my c term and confirm my a term, because that's the key. The a term has to get confirmed by the other piece. So this will be pretty easy with 2 integers, right? So sum, add them up, right? 2 plus 4 equals 6. Well, we know the sum of the roots is negative b over a, right? So that tells me that this would be -6 over a, probably a 1, right? Let me just white out and put a 1, because if you just added those up to get an integer, then that integer can always be put over 1. So far I've got a equals 1 and b equals -6. Okay, so far. Now I do product. Multiply. Product is multiply. 2 times 4 is 8, right? Well, I know that the product of the roots is c over a. So that would be 8 over 1. And again, my a gets confirmed to be 1. My c is 8. Now what I do is I take my a and my b and my c, and I put them in as coefficients in standard form. So it's quadratic equation. That means a is 1, so x squared minus 6x plus 8 equals 0. So because they said equation and not function, I want it set equal to 0. Let's try again. So over here, I'm going to add these 2 things up, and then I'm going to multiply these 2 things together, okay? See what I get. So sum, let's add them. 2 plus radical 7 plus 2 minus radical 7. So combine like terms. 2 plus 2 is 4. And radical 7 minus radical 7 is 0. So guess what? My sum is 4. Okay? So that means since my sum is negative b over a, that means I've got -4 over 1. And so my a so far is 1, and my b so far is -4. Okay? Now let's try product. So the product of the roots means to multiply them. So 2 plus radical 7 times 2 minus radical 7. Oh, those happen to be conjugates, which you can plug into your graphing calculator to multiply. That's the one thing we are actually allowed to do. Go 7 and then arrow out and put your end parenthesis. It's one of the things for radicals that we're actually able to put into our graphing calculator to solve, because conjugates for radicals will multiply together to give me a rational number, which is -3. So that now confirms to me that because the product is c over a, and I got -3 here over 1, that confirms to me that my a is 1, my c is -3, and I sub all that in. So x squared minus 4x minus 3 equals 0. There you go. Okay. Not as hard to add and multiply those as they look, right? We've already talked about that in in chapter 4. So we knew how to do that. Okay, how about imaginaries, right? So imaginaries add and multiply. So sum equals 2 plus I plus 2 minus I. Well, combine like terms, right? The i's cancel out. 2 plus 2 is 4. So since sum is negative b over a, you get negative 4 over 1. So let's confirm this before we completely know that our a is 1. We'll confirm it in our c term, but we do that by product, right? So the product is 2 plus I times 2 minus I. Again, with the conjugates, again, we can come to the graphing calculator. So 2 plus I times 2 minus I is 5. And what that means is, since the product is equal to C over A, that means we've got 5 over 1, which means our A term has been confirmed and our C term is 5. So now we sub those in. X squared minus 4x plus 5 equals 0. I saved the fraction for last because I actually think that you will find the imaginary easier than the fractional. So when it comes to fractions and adding, you need to have a like denominator. So this, if you want to turn in any whole number into a fraction, you put it over 1. We need to have a like denominator here of 4. So that means multiply top and bottom by 4. We get negative 4 over 4 as the fraction we're going to use to add with this fraction, okay? So for sum, add them up. 3/4 minus 4/4 is negative 1/4, which right now tells me, since sum is negative b over a, right now I've got the negative of negative 1 over 4. So that means 1 over 4. And that means my b is 1 and my a is 4 as of right now. Okay, but let's confirm that a value in the product. So product means to multiply with fractions, and multiplying, you do not have to have a like denominator. Okay, so I am going to just have 3/4 times 1, negative 1, over 1, which gives me negative 3 over 4. Look at that. My A term got confirmed, right? Because the product is C over A. So my A term got confirmed, and my C term is negative 3. So take and plug that in. I know I don't have a lot of room to write my equation, but that is what I was asked for. So x squared, I'll do it up here. 4x squared plus 1x, or just x, minus 3 equals 0. That is my equation. So you can use knowing the roots to then go backwards and find the equation they came from. Okay? Lastly, if I know parts of the equation and one of the roots, I can also find the rest of the equation, the rest of the roots. Okay? So that's what I'm going to do here. In this case, I know what the B term is and the A term. And I also know one of my roots, right? So that means I can go backwards to find the other root using the sum rule. Okay, so I'm going to write out the whole sum rule this time because I know one root and not both roots. And the sum is equal to negative b over a. So let's plug in all the pieces we know. By the way, if a is 1, do I have to sub it in down here? No, I know that that's a 1 there, so I just use the opposite sign here. So I know 3 plus R2, right? This is the other root, needs to equal the negative of -5 or just 5. So what is R2? The second root is 2. Okay. Now, if the second root is 2 and the first root is 3, if I multiply those together, I get 6. The product rule is C over A. You know A is 1, so what's C equal? 6, or in this case, sorry, K is what they had in place of it. I know K equals 6. Now it does say complete the quadratic equation, so I need to rewrite the whole thing. X squared minus 5x plus 6 equals 0. I found K, used it to plug back in. Now notice this time, K is the B term. So now this time I'm going to use product backwards, okay? Because I know what my C term is, and I know one root. So R1 times R2 equals C over A. Again, I know my A is 1 this time, so I don't need to put that in here. I know root 1 is 3, and then we don't know R2, but we do know C is -12. Well, okay, divide both sides by 3, R2 has to be, or root 2 has to be -4. So now let's use the sum rule to help us. 3 plus -4 equals -1, right? Well, we know that the sum is negative b over a. We know a is 1. The negative of negative b is positive 1. So we know b equals 1, which means k equals 1. Plug that back in, x squared plus x minus 12 equals 0. Or you can put that 1 in front of the x. Either way works. Use these examples to help you on your homework. I am also happy to be doing your homework with you in class. More than happy, because I love this stuff. It's so much fun to see these patterns that emerge here because of these relationships that the roots have to the actual values in the equation in standard form. It's awesome to see all this stuff come together. Okay, so please make sure you're memorizing the sum and product of your roots formulas. Make sure you remind yourself that sum means to add and product means to multiply, because if you don't know that, it's going to be really hard to distinguish later on when you're actually taking the roots and adding them or multiplying them, right? Okay, guys, good luck. Do that practice. Let me know what you need. Happy to help you. Have some fun with it though too, because these ones are a lot of fun, sum and product. See you soon. Bye guys.